This is the Chapter 8 review notes. And we start out with a scalar. Remember, a scalar has magnitude only, or just really just one measurement. And a vector has magnitude and direction. Keep in mind that if you're weighing something, that's actually a vector because we know the direction is down. Here we have, rather than getting out protractor and ruler, we're just going to give you these rays, and we want you to diagram 2a minus b. And when you do this, don't forget to have the resulting vector. So let's look at 2 times a, up 1, 2, 3, and left 2. So up, let's say we start here. Let me get a different color. What is it? 1, 2, 3, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Right there, and I'm going to cheat because I get this little 2 right here. There is, that is 2a. Right there's 2a, and then minus b, so we have to go in the opposite direction. Up 1 over 1, 2, 3, 4. So down 1, 1, 2, 3, 4. Right there, and then when you need to draw the resulting vector, right there. Let me throw a couple arrows on here, like that and like that. So here's the result. If a is negative 2, 1 and b is 3, 5, find the component form of ab and then find the magnitude. So the component form is 3 minus negative 2, 5 minus 1, which is 5, 4, and then the magnitude of ab is equal to the square root of 25 plus 16. Pythagorean theorem on that component form. So square root of 41. If r is 2, negative 1, and s is 3, 2, find the magnitude of r. That's the square root of 4 plus 1, square root of 5. Find the magnitude of 2s minus r. Well, let's get 2 times s is 6, 4, and minus 2, negative 1. Now we're going to subtract the x's. That's 4, and 4 minus negative 1 is 5. And if we're going to find the magnitude of that, it's square root of 16 plus 25, square root of again we get 41. R dot S, dot product. So 2, negative 1, do the dot product with 3, 2. So 2 times 3 is 6, plus negative 2. So we multiply the x's, multiply the y's, add them together, and the dot product is 4. How about the angle between r and s? The cosine of the angle is the dot product. We already figured that out. That's 4 over the magnitude of r, which is square root of 5. Magnitude of s, we have 9 and 4. That's 13. Let's go to the calculator. 4 divided by square root of 5 and divided by square root of 13. So that's between negative 1 and 1. That's good. Cosine of theta is 0.4961. Keep on going. We'll take the inverse cosine of the answer, and that's about 60.3 degrees rounded. Draw a sketch of each vector. Do not need to use ruler or protractor. And this is more to see if you know what 070 is, approximately. So 070 would be right there. Now, the way I'm going to know that you did this correctly, now this is if this is on paper, is you would label this 70 degrees right there. 7.6 centimeters per hour at a bearing of south 40 degrees west. So 40 degrees west on the west side of south. West side of south. So then this would be right here. This is the 40 degrees. Find a unit vector u with the same direction as the following vectors. So we just have to divide each of these by the magnitude. So the magnitude is 9 plus square root of 9 plus 4, square root of 13. So negative 3 over square root of 13 and negative 2 over square root of 13. Excuse me. The magnitude of this vector is 25 plus 9, so square root of 34. So the unit vector is 5 over square root of 34 and negative 3 over square root of 34. Find the component form of vector v with the given magnitude and direction angle. So the component form would be 6 cosine of 38 and 6 sine of 38. Now we don't know 38. That's not one of the known angles on the unit circle. So we're going to do 6 times. I got to make sure. Yeah, I'm in degrees. Good. That's good. 6 times cosine of 38. So that's 4.728. And 6 sine of 38. We have 3.694 rounded. An ant walks north for 6 inches. So north. So walks north. That's 6 inches. Well, the vector, the component form of that vector is 0, 6. There's walking north. West for 3 inches. So here's the new vector right here. The component form of that one, and we're going to add this, is negative 3, 0. And then south 1 inch. So south 1 inch. And the vector, the component form of that would be 0, negative 1. Express the path of the ant as a linear combination of I and j. So negative 3, we're adding these. Negative 3, 5. So negative 3i plus 5j. So we would go negative 3 and up 5, and I didn't really draw that to scale. Show that negative 2i plus 4j is perpendicular to 6i plus 3j. If we take negative 2 times 6, we get negative 12 plus positive 12 is equal to 0. The dot product is equal to 0. They are perpendicular to each other, and we say that they're orthogonal. An airplane is flying 20 degrees south of west at a rate of 320 knots. South of west, so on the south side of west. So we should probably start the plane over here. 20 degrees on the south side of west. All right, like this. Where, let me extend this a little bit, where this is the 20 degrees and the magnitude is 320. A wind with a direction 20 degrees east of south. 20 degrees east of south is pushing the plane off course. So 20 degrees east to south. And this right here, this would be the 20. And the magnitude is 30 knots. What is the speed and direction of the plane? So then the path looks something like that right there. We need some unit circle measurements. So this would be 90, 180, and another 20. We're looking at 200 degrees, but that's for, what is that for? Do I want that? Oh yeah, because we started that way. All right, so there's 200. Then we need 180, 270, 290. So 290 degrees. All right, so the plane is 320 cosine of 200 degrees, and then 320 sine of 200 degrees. The wind is, let's see, the magnitude is 30. 30 cosine of 290 and 30 sine of 290. So the resulting vector, the resulting path, 320 cosine of 200 plus 30 cosine of 290. And we get negative 290. Negative 290.441, comma, and then 320 sine of 200 plus 30 sine of 290. Negative 137.637. Oh, I need to store those. I'm going to go back up and store those. So store this in A. Let's go to this one, and we're going to store that in B. So I have this in A, and I have this in B, so we need the magnitude of R is equal to the square root A squared plus B squared. Let's do that on the calculator. Square root of a squared plus b squared. So the magnitude or the speed is 321.4, and that's going to be knots. The angle is inverse tangent of b over a. Inverse tangent of b divided by a. Let's see what we get. We get 25 degrees. 25 degrees, but let's see, what would that be? That would be this. It would be right here. That's what it's giving us, 25 degrees. Now let's think about how the angles have been given in this problem. And by vertical angles, I had to think about the word. This is 25 degrees right here. So that would be, well, first of all, we get 25.355, but we're going to say 25 degrees, and it's south of west.